Alright, Introductory Robotics. Let's talk about blinking some lights here. This may be your first taste of working with Arduino, and this is one of our final modules because we're bringing together a whole lot of concepts that you've already touched on, but maybe you haven't gone a lot in depth with. What we're going to go through today is we're going to talk about the electronics involved in blinking this LED, and then we're going to talk about the code in blinking this LED. And we're going to keep it very simple because this is supposed to be one of the beginner things. Often in coding, this is referred to as what we call a hello world moment. When you code, usually the first program that you create is a way of making the computer tell you hello world, meaning hello, I'm here, I can respond, I can communicate with my world. In this case, we're going to use this little red LED here. Actually, we're going to change this thing's color, I think, if I can. Oh, perhaps not. There we go. And we're going to make it blue. We're going to make it green so you can see it more easily. All right. Now, in Tinkercad, I've assembled what you should already have. You should have a basic circuit of how to actually make an LED turn on. And we can call this basic LED circuit. And I do recommend naming your files. It makes them much easier to find long term. And we know that when we start the simulation with this one, we get a very bright green LED. That makes sense. I've swapped out something that you may not have on here. I put a 470 ohm resistor on here. It's one of my favorite sizes. It works really well for this particular size of LED, and yeah, we're going to get that to roll. Now, from here, you'll notice that I've created the very simple circuit. We've got 5 volts on one side running through a power rail, running out to our terminal strip that runs through our LED, through our resistor, back out through ground, again, through a power rail, and into ground on the Arduino. Now, you'll notice that your Arduino has 3 ground points, here, here, and here. They are all the same. They're what we'd call a common ground. You can connect any of those, and they basically create the same electrical effect of a negative pole and something that you can actually connect your circuits with. Now, the question here is, we want to be able to actually run this LED using our Arduino. Now, the Arduino actually has a built-in LED. And one of the things we notice when we start the simulation is that this L button here actually, and I'm going to zoom in on this a little bit so you can see it, this L button here, this represents the LED that's on the board, or the LED built in. And you'll notice that it is actually blinking. And that's actually due to code. And we're going to base what we're going to do here on that particular piece of code. So let's take a look at that code first and see why that LED is blinking. Stop our simulation. We're going to go up to our code. Now, you notice when you start with code, you get this block-based code. And it's kind of cool. It just shows set built-in LED to high, wait 1 second, set built-in LED to low, wait 1 second. Now, that's pretty simple. We're going to do the same thing, but we're going to use the actual Arduino coding language. Now, Arduino is based in a language called C. C is very common. You see it all over the place. Java is a version, a flavor of C. Arduino, C++ is a very common one. I've often referred to Arduino as C-. It's C minus a lot of the fancy stuff that exists in C++, and it runs hardware really effectively. So we're going to hop down to text, and it's going to say, "Are you sure?" Yes, I am. Now, you notice that what you get here when you do this is that you kind of have reduced this down to a few lines of code. I'm going to actually zoom in on this a hair just so we can see it and we can talk about it. Now, your Arduino code is going to start with 2 basic things. It's going to start with a line that says void setup, round brackets, followed by curly bracket, curly bracket. Now, I want to explain each piece of this. Void, in this case, is simply meaning that this is going to not return data. That doesn't mean anything to you non-computer science people, and then you should just leave it that way. It's not a big problem at this point. Setup means that this is going to run this code in these brackets once. Now, if you're looking down the page, you're seeing something that says void loop. Void loop is actually a command that's going to run the things in these brackets here as many times as it can. It will keep running until the batteries run out, the power turns off, or it ends for another reason. And up here, the setup is going to run the code in here once. It runs everything between these curly brackets here, line 2 and line 4. Likewise, the void loop is going to actually run everything between line 7 and line 12. Now, those 2 commands need to be in every Arduino program that you run. If they are not there, the Arduino will actually throw an error. It will not function. It will not do what it's supposed to do. Likewise, one of the most common things I see with students is they forget to put this last parenthesis on the back, the round bracket, or sorry, the curly bracket. And when they do that, they actually, let's take a look. When I try to run my simulation with this, error, something is wrong. In function, void loop. Okay, on line 14, we expected a curly bracket at the end of the input. Look at that. Okay. Sorry, between 11 and 14. Let's put that bracket back in. Let's check our simulation. Now, what you notice here is that this is actually doing some stuff. It's doing, on line 3, it's going pin mode. Now, We have some commands in Arduino, and I'm going to explain them here, but I'm going to show you how to find the solution to them. If you are ever lost with an Arduino command, go up here and just go to the Arduino reference. Okay. Now, most languages have something like this. The Arduino reference is a website that's on the main Arduino site, which is arduino.cc. It is a Creative Commons language. You could use it to make your own product if you wanted to. Now, that being said, if you go into here, it'll actually tell you all of the different commands that your Arduino will understand. Now, we've got one there that says pin mode. So let's look up pin mode very simply. I'm going to go find pin mode right here. Now, I'm going to read the first part out to you. Configures the specified pin to behave either as an input or an output. See the digital pins page for details on the functionality. As of Arduino 1.01, it is possible to enable the internal pull-up resistor. We're not going to worry about pull-up resistors at this point. We're going to deal with that in another video. Syntax. Now, syntax means how you're going to write this, and this piece is really important. In this case, it's pin mode, round bracket, pin, comma, mode, close round bracket. Now, at the end of this, we are going to put a semicolon. More on that in a little bit, but there's some notes there. Under parameters, it actually tells us what data we are expecting to put into those two pieces of syntax. Under pin, it says the Arduino pin number to set the mode of. That kind of makes sense. We have to tell it what pin we're telling it to change. Now, the pins, when we use the term pin, we're talking about an electrical connection, and they can do a variety of things. They could be sensors, they could be lines to send voltage out, bring voltage in, all sorts of things. In this case, we're just going to pick the pin we're going to be working with. Now for mode, it says either input or output. And if you notice in the reference, they are completely capitalized. And that is important because capitalization matters. I know your English teachers have been harping on you about this for the better part of a decade, but capitalization and spelling matters in coding, because if you spell a variable name wrong, if you spell a command wrong, your computer doesn't know what the heck you're talking about. And that's a problem. Now let's go back to Tinkercad and let's break down this code. So pin mode, pin number 13 is going to be an output. Now that kind of makes sense because everything we're dealing with here is LEDs. They are supposed to basically be outputs. We're outputting a light. We're outputting a motor. This is as opposed to an input, which is where we'd input a button. We would input a light sensor. Anything that senses is usually an input. Anything that actually sends energy out is an output. Now let's hop down to our void loop here. We've got 4 lines of code. Luckily for us, they repeat a couple of times. So let's work on line 8. Line 8 says digital write, pin 13, high. Now I'm going to explain this one for you. This one actually says digital write, meaning we're going to either send voltage out that is high or low. It is either a 1 or a 0. It is either on or off. Those are our only 2 choices if we deal with digital anything. In this case, digital means on or off. It means that binary 1 or 0. So in this case, pin 13 is actually going to receive high voltage. It's going to pour out as much voltage as it can onto that digital pin 13. That kind of makes sense. When I say lots of voltage, I'm talking about 5 volts at, in the case of an Arduino board, a reduced milliamperage. It won't blow up the LED unless you forget your resistor, but we talked about that last week in some of our Ohm's Law stuff. Next, we see a command. Oh, and before we go there, notice that there is a semicolon at the end here. At the end of each of our commands, we put a semicolon. That's simply telling the computer that you can move on to the next command. We've done what we need to here. If you don't have that, again, large error. It will tell you, hey, something doesn't make sense for me right now. There you go. Okay, in function void loop on line 9, which is right here, okay, expected a semicolon before delay. When we go back to the line before it, we realize, hey, there's no semicolon there. That's problematic. In delay, we see that it says delay 1000. And in the comments here, and this is kind of cool, it says wait for 1000 milliseconds. The comments are anything that comes after these 2 slashes. When you put these 2 slashes, the computer is going to ignore everything in here that's in orange right now. And that's important for you because as the coder, you want to leave good comments so that you know what you wrote and why you wrote it. And that actually is going to be key to you understanding the code. It's key to your teacher understanding what you've created as well in some cases. With this case, we see 1000 milliseconds. Now we know, based on our metric prefixes and understanding some basic pieces of numeracy, that milliseconds is 1/1000th of a second. In this case, that means that we are waiting for 1 full second. Okay, again, we put our semicolon at the end and we go on to our next one. This one says digital write 13 low. And the low simply means that this is now going to send 0 volts, or a low signal, to that particular pin. In essence, turning the pin on, turning the pin off. And since this is a loop, we're then going to go back to the bottom, and we're basically going to go on, off. 1 second between each. Back to the top. Here we go. On, off, on, off, on, off. This will happen until the end of time, as I said. I'm going to close this down. This is actually doing exactly what it's supposed to, because this L right here, this LED that's built into your Arduino board, oops, is actually attached to pin 13. But what if we wanted to attach our LED to pin 13? Well, let's mess with our electronics a little bit here. I'm going to stop my simulation. I'm going to take this wire that provides 5 volts to my LED normally. There we go. And I'm going to delete it, just make it go away. I'm going to take a line or a wire from pin 13, and I'm going to drag it over to the positive side of my LED. Now, I'm a really big fan of cleaning up my wires so they don't all cross each other, so we're going to do that right here. There we go, line them up, nice 90-degree angles. Okay, I got a nice green wire coming out of pin 13. It's going to run over to my LED. Now, theoretically, what this should do is when I click Start Simulation, it's going to send a digital signal to that LED, turning it on for 1 second. So I'm going to wait for the rest of that second, and before it sends a low signal, turning the LED off. It's going to alternate this for as long as I let this simulation run. Now, in real life, this is going to run until the batteries run out. It's just going to keep turning the LED on and off. That is the basics of how Arduino code is structured. That is the basics of how you wire an LED. That is the basics of how digital write, the command, works. And that is your hello world.